Today we're going to look at some examples and proof statements about segments and angles. This is more about a how-to and definitions. So the first thing we have is vocabulary and proof, two-column proof, and theorem, and kind of want to work backwards. A theorem is a statement that can be proven, and the way you would prove that we're going to do in geometry is a two-column proof, which has numbered statements and corresponding reasons that show an argument in logical order. And then you do the proof, which is the logical argument that shows that a statement is true. So, for example, we have two columns here, and we are to prove that given we're going to prove that angle 1 equals the measure of angle 4. So these two angles here. And it's given information. It's saying the measure of angle 2 equals the measure of angle 3. And the measure of angle AXD equals the measure of angle AXC. So when you start your proof, you write down the given first, and you just write given. And then we're going to say the measure of angle AXD. So here's your X. X is the middle here. So AXD, so from here to here, equals the measure of angle 1 plus the measure of angle 2. So basically, here's your angle addition postulate that says when you have measure AOC, and it's just saying that these two add up to that. That's your angle addition postulate. Once you say that, you're going to do the other one too. So we have to do the other angle, which would be measure of angle AXC. So that one is AXC, and we're using the angle addition postulate again. So then you can use substitution. We know that measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4, because this is given. And we just use substitution. So we substituted this in for this one, and this in for that. All right. Then we did our given again. So we have another given, this one. Then we used subtraction property of equality. And basically, it's kind of hard to see there. So basically what it's saying is measure of angle 1 plus measure of angle 2. Let me move it down a little. So let's move it down. Measure of angle 1 plus measure of angle 3 equals measure of angle 3 plus measure of angle 4. And we're subtracting measure of angle 3 from both sides. So that's basically what that's about. And we get measure of angle 1 equals the measure of angle 4. And that's a subtraction property. Okay, we have two theorems, congruence of segments and congruence of angles. And we have reflexive, symmetric, and transitive. And for angles, it's the same thing, reflexive, symmetric, and transitive. So basically, here we have angles. So we're looking at this, and it's saying if the measure of angle 5 is congruent to the measure of angle 3, then the measure of angle 3 is congruent to the measure of angle 5. And that's where you're coming to this theorem, the symmetric property of angle congruence. All right. We have an example of 3 steps of a proof. it's saying given that AC or BC, and so this has to be B right here. Prove that AC equals AB plus AB. So, since these two are the same, we have BC equals AB, that's given. We know from the segment addition postulate that this side plus this side, when you add those two up, so if this was 2 and this was 3, then this whole length would be 5. That's basically what it's saying. So we're going to add this up, and then I'm going to use my substitution property because it's saying that AB equals BC. So right here I substituted my BC with AB. All right, and number 2, it says name the property illustrated by this statement. This is angles again. We're down in here. So basically, since we have if angle H is congruent to angle T and angle T, these have to be the same. Angle T is congruent to angle B, then we can go from there to there. And that's your transitive property of angle congruence. Something like if A equals B and B equals C, then A equals C. That's if, then. Okay, the next one. Here's another example. If we know that BD bisects this angle, that means these two angles are the same, because bisect means in half. All right, so these would be the same, or the lines would be the same. So we need to prove that the measure of angle ABC, this whole angle, equals 2 times measure of angle 1. So I'm going to rearrange this a little bit. So this is measure of angle 1, measure of angle 2. So what we got to prove is that measure of angle 2 equals measure of angle 1. So we write down the given. You always write down the given. Measure of angle 1 is congruent to measure angle 2. These two are congruent because the definition of an angle bisector. That means they the measures are equal, and that's definition of congruent angles. We already talked about the angle addition postulate. So when you add these two up, it's going to equal the same, the whole angle. That was from the previous example we used. So when I add these two angles up, it's going to equal the whole angle. And then we're going to substitute. We know that measure of angle 1 equals the measure of angle 2. So I'm going to substitute my measure of angle 2 with that because they equal. So that's the substitution property. And there's 2 of those. So you just say 2 times that equals the measure of angle ABC. And that's the distributive property, because 2 times A equals A plus A. All right, and next one. We have a multi-step word problem. I'll let you look at this one. We are trying to prove that M is the midpoint of R and B. So again, you just write down the given. R is the midpoint of A and M, and then definition of the midpoint, and so forth. So look through that and I'll let you do this one on your own by looking through that. It looks hard, but it's really pretty easy. And finally, we're using right angle congruence. Right angle congruence means that given angle A and 2 are right angles, that means all right angles are congruent because all right angles are 90 degrees. So 90 equals 90 degrees. So we're going to write a proof giving that these are perpendicular lines. JK is perpendicular to KL, and ML is also perpendicular to KL. So we want to prove that these two are congruent. So we write down the given. Definition of perpendicular lines means they're right angles. Therefore, angle K is congruent to angle L, and that is based off your right angle congruence theorem. And that's it. Thank you. Have a nice day. Bye-bye.